Examples from SQL Zoo. The URL for SQL Zoo is sqlzoo.net. That's not .com, it's .net. And these four examples are going to use this table we're looking at right here. This table is not the table in its entirety. This table would go all the way down to the Z's, so Zimbabwe and so on. But it's data for countries in the world. And we have four examples we're going to go through. Let's take a look at the first example. SQL Zoo is great because we can get instant feedback on our queries. So this first query is giving us the population of France. If I click Submit SQL, it's going to run and show me the result over here on the right. We're asked to modify it to show the population of Germany, but before we do that, let's take a look at our existing SQL code. We have three SQL keywords, and those are all capitalized. And let's take a look at the first one. So select, following that word is going to be all of the fields that we want to show in our results. And we're only showing a single field, that's the population field. Next, the from statement, following that is going to be the name of the table that we are getting this data from. And that name of that table is world, so that's good. And then where, the where clause is where we're going to filter our results, where the name field of this table equals France. So we're just going to get a single line. And so the change to make this work out is very simple. We're going to change France to Germany. And notice that we put the name of that country inside of single quotes because this is a string field. If it were numeric, we would not need to do this single quotes. But since it's a string, a combination of alphanumeric characters, we use single quotes. And so now if I submit this query, it's saying I do have the correct answer, that the population of Germany is just over 8 million. And before we move on to the next one, I just want to show you that we could put other fields inside of this select clause here. So say I wanted to put the name of the country as its own column here to the left of population. I can do that by typing the name of my field followed by a comma. And when I submit this, it will say it's incorrect because the result was just looking for the population field. But now I'm seeing that Germany has a population of just over 8 million. And another little trick, say I don't like this word name up here, I think that this should say country up here. And I can do that easily in SQL by using the as keyword. So select the name field, but treat it as if the name of that field were country with a capital C. And now when I submit SQL here, I'm going to see country up here. That's the only change I will get. Let's move on to the next example. So this example shows us that not only can we use field names inside of SQL statements, we can also use calculated fields. I'm just modifying this to put the select from and where statement on their own line. So select name and then population divided by area. Now population divided by area is not one of the existing fields in our table, but we can calculate that field. And so when I submit this query as is, I'm looking at population density right now, population divided by area. And if I want to show that as density, I can do that to make it look a little more clean. But we are asked in this example to show GDP per capita. So GDP divided by population. And the where clause is going to be the same. We still want this just for large countries, countries that are greater than 50 or 5 million square kilometers. And so to calculate GDP per capita, we are going to do GDP divided by population. Let me make sure I have the correct fields there. GDP divided by population, that looks good. And we're not going to use an as statement just so we can get this correct. And let's submit SQL. And there is our GDP per capita for those countries where the area is greater than 5 million square kilometers. That's the correct answer, although say I wanted to display that second column as GDP per capita. I could do that and see a cleaner column title than the calculation for my calculated field. Next, inside of the where statement, we can use another SQL reserved keyword called in. And in is used if we want to have a list of possible values. So right now we're getting the name of the country and the population of the country for 3 countries that we've named here: Luxembourg, Mauritius, and Samoa. And we want to show these same 2 columns, these same 2 fields, name and population, but for these 3 countries: Ireland, Iceland, and Denmark. And so I can do that just by changing the text inside of this in clause here. Ireland, Iceland, and Denmark. Submit that, and that is the correct answer for those 3 Scandinavian countries. Another thing you note here is that this SQL statement ends in a semicolon. The semicolon is optional to end your SQL statement, and whenever you have multiple SQL statements that you are evaluating at the same time, it's required, because I would start with a new select statement down here. If it's just a single select statement, it's not required, and some people like to put them in anyways, just because that gives them, the human reader, a tell that the line of code is over. This is in all C-based languages, you're going to see a line of code end in a semicolon, like C# or Java. Very good. Let's move on to number 4. So this is another keyword we can use inside of the where clause or after the where clause, and that's this reserved SQL keyword called between. I'm going to clean this up a little bit first. We're getting the name and the area of all countries that are between 250,000 and 300,000 square kilometers. And we're asked to modify this to get us between 200,000 and 250,000. So if we submit as is, those are all the countries that are in that size range. And if we make the change they are looking for, that should give us the correct answer. Those countries are between 200,000 and 250,000 square kilometers. And so to use this between keyword, where area, usually you see something like this, where area equals 200,000. Instead of using the equals after the name of the field that you're filtering on, we use this reserved keyword between. And then after the word between, we need to have 2 values separated by the other reserved SQL keyword and. So between always has to have this word and in it. And so we're getting all results between these 2 values. And also these values are inclusive. So if you do have a country that was exactly 200,000 square kilometers, it would show up in these results. If you had one that was exactly 250,000, it would show up in these results. So we call that inclusive because the query results would include this lower bound and this upper bound here.